Alright, this is lab number 4, Pig Latin. And as per the usual, let's go through it step by step. First and foremost, you see we have our two major classes, Pig Latin Activity, Pig Latin Translator. So let's get into them. This is our activity class. And what I want to pay special attention to is the public void translate view V and public void clear view V. These are actually linked to buttons within our application, which I can show you within our XML, or activity XML. We have 3 buttons: speak, clear, and translate. Translates on click method is linked to the translate back into the Pig Latin activity, and the clear function is linked to the clear, again, our Pig Latin activity. Okay, you see a brief rundown of what it does. Edit text gets the ID of our input text. String text is being assigned to edit text.get text to string, convert to a string. Set English text. Our engine, which is our method that we define in our second class, which we'll get to eventually, is being set to our new English. String result equal engine dot get pig, again within our Pig Latin translator class, which we will get to in a moment. And then text view, converted text view, again, just locating the ID of our text view, the output in this instance. And the converted text is equal to dot set text, the parameter result, which we defined earlier, which is right here. And clear, which is part of the advanced section of this lab, is basically just reiterating the last 2 components, lines of code from translate. We assign string result equal to nothing. It clears it, text view, convert text view, find view, locates the ID again, and convert text equal to our new result, which is nothing. Empty string, not nothing. Completely different. And then let's get into our Pig Latin translator.java. Here we have a number of methods actually. So we have our Pig Latin class. We identify our fields that we're going to use. Public string.get pig, return this.pig. String translate. Tokenizer, st equal new string tokenizer, this.english. String result, empty string, while string has more tokens. This is really important because what string tokenizer does is it splits up any sentence you may enter into this application into words based on spaces. So here we have our string tokenizer equal new string tokenizer, this.english. It takes the input of the sentence you inserted into this program and it identifies each space. And at each space it cuts the sentence, isolating exactly that word. So for instance, if I were to say this is a program, this will be a word, is will be a word, and program will be a word, because it has a space in between each word. Hopefully you get a better idea of this when I execute the code. So string word equal st.next token, string pig, this.translate word. If result.length is equal 0, result is equal pig, else result equal pig plus empty string plus pig. Nothing complicated here at all. Moving downwards. Now this is the major bulk of the program that the computer science had to program during this lab. So as you see here, we have our string result equal to word, string cut, all these variables defined by myself, string remainder. Hopefully these words are given enough meaning that you can figure out what is going on. Now we initiate our arrays, so return the arrays, car vowels, bracket equal, curly bracket, A, E, I, O, U. And this is how you implement an array. Boolean vowel equal true. Again, this feels. And now let's get into it. For int I is equal to 0 while I is less than result.length, I plus plus, in characters equal to result.character at I. Therefore, this will iterate as long as it has a word with the word's length over. So if our result starts with an A, it's a handy expression, starts with, very convenient. Or result like a Caesar R statements for each vowel. This could have been done a lot more efficiently with looping via the array. However, unfortunately, I was not able to do it. So that's something to research into future labs. So I just used a very long series of OR statements in my function. Name if statement. If vowel will be equal to false at that point, because we look here that it does in fact have an A, E, I, O, U. Vowel is equal to false, and the program will no longer initiate. And return result. Else if character equal A, or again a series of A, E, I, O, U statements. Again, an array will be a lot more efficient at this. But since it's looping through the entire length of the word, as per our for loop, even if it does not look here at our first point, it will go down to our else if statement and cycle through every portion of our word, looking for these exact words, A, E, I, O, U. At that point, it will locate a position in position is equal to I. Cut is equal to result of substring 0 to position. And what that will do is cut the word at the position where it found a vowel in the word. So if it were, let's say, it could go with the vowel sheep, it would take off the SH, cut that off, and now we will cut. The remainder will be a result of substring the position, which will be the EEP, so the EEP. And then finally we will declare our new result as the cut, the EEP, the remainder, EEP plus the cut, all it has before the vowel, the first vowel located, plus A. So that handles our second condition. And our last condition, else if we have exceeded our I more than equal to result dot length, you have not located a vowel, and vowel equal true, it will simply return the result plus A, which means that the word entered has absolutely no vowels and meets our third condition, which is just going to be the result plus A. And return result, and that's basically it for this lab. The second video will show you the application in action, and hopefully that will be it.